Hello, welcome to day 6 of our notes on angles formed by secants, tangents, and chords. So first of all, we have to define what a secant is. A secant is a line that intersects a circle in exactly 2 points, forming a chord. So this line you're seeing right here, J, intersects the circle at 2 points, so that means it's a secant. The segment then that's created between those 2 endpoints is called a chord. So our first theorem has to do with secants. So the measure of the angle formed by 2 secants or chords is equal to 1/2 the sum of the intercepted arcs. So here's what this means. If you want to find the measure of angle 1, okay, I want you to focus on angle 1 and its vertical angle. The arcs that are intercepted are what I just highlighted in green. Or in the notes, if I actually take that away, you'll see it's already in red right here. So DC and AB. So what this means is angle 1 and its vertical angle, technically, is equal to, okay, it says half the sum of the arcs. So I'll say AB plus DC divided by 2. You may see some teachers even write it like this: 1/2 AB plus DC. It's the same thing. Now, the reason I personally write it as AB plus DC divided by 2 is because I think of it as the average. When I have these 2 intersecting secants, these angles are equal to the average of the intercepted arcs. Now, let's say you wanted to find the measure of angle 2, and technically its vertical angle. Okay, the intercepted arcs would be BC and AD. So angle 2 would be AD plus BC divided by 2. Now, something I personally don't like about this diagram right here is it looks like this point right there is the center, and it technically could be, but this rule that we're applying means that this intersection, like if you look at example 1, is definitely not the center there. So this could move anywhere in the circle. Okay, so if I look at this guy at example 1, if I want the measure of angle X, it's technically angle X and its vertical angle, so those are congruent, and then you look at their intercepted arcs. So again, what I was saying is that angle X, that's definitely not the center of the circle, so that is not a central angle. So angle X is not equal to 130, but angle X will be equal to the average of those intercepted arcs. So X will equal 130 plus 84 divided by 2, which is 107 degrees. Now, if I want the next guy, okay, there's angle X, there's its vertical angle. Now is a point where I would say pause the video, see if you can try that one, and then when you're ready, play the video again to reveal the answer. All right, are you ready for the answer? Here it is, 81.5. So you should have added 116 plus 47 divided by 2, 81.5 degrees. Okay, coming on down to C. Now, this one's a little bit more interesting because you'll notice X is located over here, which has nothing to do directly with these 2 arcs. So I want you to notice that 75 intercepts this arc right here, or I'm sorry, 75 intercepts this angle, CED, and same thing with angle AEB that's intercepting 43, and X is over here. So here's what I'm going to do. Let me actually erase this to clean it up a little bit. Let's call this angle right here Y, okay? Because I can use what I know about finding angle Y to then do a linear pair to get angle X. So with that being said, angle y and its vertical angle would mean you're going to sum 75 and 143. So 143 plus 75 divided by 2, because it's the average of those arcs, and that would give me 109 degrees. Now we know angle x plus 109 degrees must equal 180, because again, those are a linear pair. So if I subtract 109, x would equal 71 degrees. And that's how you'll do a more complicated problem like that. So I'm just going to circle and star that one because students tend to forget that. So with that being said, now that you've seen how I've done C, I'd like you to pause the video, see if you can try D, and then I'll reveal the answer. And here's our answer. 115. Okay, so you guys should have found that that angle y was 65 degrees. And then, like I said, here's your linear pair. So that means those angles are supplementary, so I get 115 for angle x. Okay, moving on to the next page. Now here's a word that I said at the very beginning of the video that I haven't yet defined yet, and that's a tangent. Now a secant intersects a circle in two places. A tangent intersects a circle in exactly one point. So right there would be your point of tangency. Okay, so our first theorem that we're going to use that has to do with this is a secant and a tangent intersect a circle at the point of tangency. So again, here's your point of tangency. Then the measure of each angle formed is 1/2 the measure of the intercepted arc. Okay, so what this means is angle 1 that you're seeing in the diagram, which is created right there, is going to equal 1/2 of AB. That would be its intersected arc, which you can see in red. Angle 2 will be 1/2 of its intercepted arc, which would be BCA. Okay, so for example, if I were to throw some numbers in here just to give you context, let's pretend that angle 2 is 100 degrees and angle 1 is 80 degrees, which would make sense because those would be on a line and they'd be supplementary, so they're linear pairs. Okay, so that means that BCA must be double that, which is 200 degrees, and double 80 would give me 160 degrees. Now this should make sense because 200 plus 160 makes 360, which is how many degrees are in the circle. Okay, so in my first example down here, which says technically example 2, says find each measure. So if I want the measure of angle QPR, so QPR, here's your tangent, there's your point of tangency, there's your secant, and then here is your intercepted arc. So 1/2 of 148, or 148 divided by 2, however you want to write it, is equal to 74 degrees. So that would be the measure of angle QPR. Now this one goes the other way. I want the measure of arc DEF. Okay, now DEF would be our major arc because I've included that extra letter there that shows I'm going around the outside. I can find that by first finding the measure of arc DF. Okay, so what I'll do, again, here's a secant, there's our tangent. This means that I can double 64, and that gives me 128. Now, we know that there's 360 degrees in a circle, so I can subtract 128 degrees, and that would give me 232. And that's the measure of DEF. Now, if I'm being completely honest with these diagrams, I really should have stated in the problems that each of these were a tangent and a secant. on a test or quiz or something, we would explicitly say to you that, for example, QP is tangent to the circle and set line or ray PR intersects a circle at two places, etc., etc. Like, it'll be very obvious. Okay, so we'll just assume, because we're seeing that one intersection, that this is tangent. All right, so now a little extension upon this theorem gives us the next one. So in a plane, a line is tangent to a circle if and only if it is perpendicular to a radius, technically, or diameter, drawn to the point of tangency. Okay? Now, the reason that this is true, so here's your radius, here's your point, here's your line, your tangent, there's your point of tangency. The reason this is true is because if I were to extend this, that technically creates a secant, which is intersecting the circle at two places. That means that it's splitting the circle in half. So that means each half will be 180 degrees. Now, just like our last theorem, if we have a tangent and a secant intersecting at the point of tangency, which again is, in this case, t, that means half of 180 gives us 90, because we're having that intercepted arc. Same idea on the other side. Okay, so this is really just a specific case of the theorem that we did up above. So I can say that we will then know, this has to be true, that line L is perpendicular to ST. All right, so we're coming on down. Here's how this applies. So in the measure of, or in the diagram below of circle A, so that means they're telling you the center of the circle is A. Tangent CB, so I know it's intersecting. Here's my point of tangency at B, is drawn to radius AB. Now, we've defined it as radius AB, but truly we should know it's a radius because A is the center, and we're drawing to the outside. If the measure of DB, or arc DB, so that's this guy right here, is 50 degrees, determine the measure of angle C. Okay, so here's what I know. If this is a tangent and this is a radius, that means these must be perpendicular. Because again, if you were to extend this, there's your secant, there's 180 degrees, half of 180 is 90. Okay, but you don't need to extend that because we just learned that this will always be true. Now, if this is the center of the circle A, that means that angle A is a central angle, which is 50 degrees. Now, you know 180 degrees is the sum of the interior angles of a triangle. Or recognize that if this is 90 degrees right there, then that means these two angles must sum to 90 degrees. So however you want to do it, I'm going to do it the latter way, where I say angle C plus 50 equals 90 degrees. So angle C must be 40 degrees. Okay. Like I said, though, you could have done 50 plus 90 plus angle C equals 180. You'll see that I end up in the same exact spot that I did in my last solution. If I subtract the 90, that's 50 plus angle C equals 90, right? And then we're at the same exact place. So it really doesn't matter, however you want to go about doing that. Okay? Okay. Now, this is the last theorem that we will use in this entire packet, so that's kind of cool. And it has to do with two secants, a secant and a tangent, and two tangents. So you're seeing 3 diagrams below, but the general idea is going to be the same for each of these. If you want to find what we're, oops, gotta turn my phone on silent. If we're going to find the exterior angle of each of these, so that's an exterior angle, that's an exterior angle, that's an exterior angle. In each case, it's going to be the big arc minus the small arc divided by 2. Okay, so I'm actually going to go through and label each of these. This would be the big arc, that would be the small arc. Big arc, small arc, big arc, small arc. Okay, and that's what it's defining up here in our theorem box. It says if two secants, a secant and a tangent, or two tangents intersect in the exterior of a circle, then the measure of the angle formed is half the difference of the measures of the intercepted arcs. So this is something that I generalized for myself even when I was in high school. This is something that I always would write out. So angle A in each of these cases is going to be the big arc minus the small arc divided by 2. Now, again, you may see a teacher write it like this instead. It's exactly the same thing. If you do big minus small times 1/2, it's the same thing as dividing by 2. Okay, so just be aware that you may see answer keys or something writing it a little bit differently. It's the same concept. All right, so coming on down. If I have two secants here and I want to find the measure of angle A, okay, it's going to be the big arc, so 134 minus the small arc divided by 2. So 134 minus 40 and then divided by 2 would give me 47 degrees. Okay, now in the next example, I want the measure of angle A, and I'm telling you the measure of CD is 130. Now, what you're seeing is that you only know the big arc here. So the question is, how much is the small arc? Now, in problems like this, where it's not immediately obvious what the answer is, you're always going to want to look for radii or diameters because that'll tell you where 180 degrees is. So if you focus on the secant, you'll notice that it makes up or creates a diameter, which means that these must sum to 180 degrees because this would be 180 over here. So that means that arc BC must be 50 degrees. So with that being said, angle A equals the big arc minus the small arc divided by 2, and you would get 40 degrees. Okay, now angle L in our next example, C, is two tangents. I see a big arc in red and a small arc in blue. They're telling me the small arc is 102. Now, you don't immediately know the big arc, but you can find it. We know the sum of the arcs in a circle is 360 degrees. So 360 minus 102 will give me 258. So now if I want angle L, it's big arc minus small arc divided by 2. So angle L will equal 78 degrees. And last example on this page, okay, I'm actually giving you the angle, you know the small arc, and you want to find the big arc. So let's call that X. So I know that angle A equals, let's actually write it like this, big arc minus the small arc divided by 2. And let's fill in what we know. We know angle A would be 56. Our big arc we're calling X. The small arc was 95. And then divided by 2. At this point, you're back in Algebra 1, and you can just cross multiply to solve. So I can do 56 times 2 and give me 112. Add over the 95, and X would equal 207. So with that being said, that means that CD is 207 degrees. Okay. Now, these last couple examples are just going to tie together some theorems that we discussed over the course of this unit. And I'm going to want you to solve for measures such as A, B, and C. And in example 5, same idea, A and B. Okay? Now you'll notice that I'll say find A, B, and C and circle A. That means A is the center of each of those circles. So for example, first thing I notice in number 5 is that means B is a central angle. Or angle A, I should say. Well, yeah, B, because it's at center A. All right, so I would say pause the video and see if you can work out number 4. Okay, those are the final answers. So I'm going to take you through this, but if you'd like to try and see if you can find your mistake, if you didn't get that, feel free to pause again. Otherwise, keep watching and I'm going to continue to go through this. Okay, so when I look at this diagram, I try to locate any tangents, any diameters, and things like that. So first thing I'm noticing is that here is technically a diameter because it's going through the center of the circle. And this must be a tangent because it's a line intersecting the circle at one point B. So with that being said, I know that those must make 90 degrees. So just something I'm marking in the picture. Might be helpful, might not. Now here is technically another secant. It's technically a chord there because it has its endpoints on the edge of the circle. So that means that this angle created here, 34 degrees, will give me this intercepted arc by doubling it. So that gives me 68. So if I want to find the measure of angle A, check this out. That's an inscribed angle. And the arc at which it intercepts is that 68 degree angle that I just located. So that means half of 68 gives me 34. And that's where that answer comes from. Now, this is where recognizing the diameter is going to come into play. Be really helpful for me. So if this is a diameter, that means that this is an inscribed angle. This whole angle here is an inscribed angle in a semicircle, which means, in other words, this whole arc over here is 180 degrees. So that means this angle must be 90 degrees. And that's Thales' theorem right there. So if I want to find the measure of angle B, I can do 90 minus 34, and that'll give me 56. Now finally, I got to find a way to get to angle C somehow. Well, again, recognizing if I have any diameters or things like that. Actually, will that be helpful here? 1 second. Well, let's look at this. I'm actually going to erase this blue part right here. I know that this is an inscribed angle. So is there a way I can figure out the measure of that arc? Well, something you may want to look at is, let me actually pull up a different color here. Let's use pink. This arc, if you look at the endpoints of it, you can trace it back to angle C, which I know is confusing. I got, angle C, capital C, and then I got a little c over here. Over here to that 52 degrees. So that means 52 times 2 gives me 104. But then if you look back at the angle that you're really looking for, there's an inscribed angle, there's the intercepted arc, so half of 104 is 52. Now, technically, you could have cut out that middleman by not even saying the 104, because if you have two inscribed angles intercepting the same arc, then they must be congruent. And that's where the 52 is coming from. Now, this is just one solution that I've taken you through on how to find those angle measures. There's technically other ways you could have done this too. So if I didn't mention something that maybe you came up with, but you still got the right answers than me, chances are you probably did it right. You just thought of something differently than I did. Okay. All right, moving on to the next one. So again, I would recommend pausing the video, seeing if you can figure out A and B. Okay, and those are the final answers. So just like last time, if you want to pause the video and see if you can find your mistake, or just wait, continue watching, and I will go through the solution. Okay, so again, when I'm looking at diagrams like this, I try to identify things that might be helpful for me to determine angle measures. Like, for example, I'm recognizing that this is making up a diameter because it's going through the center of the circle. I'm also recognizing that this is a tangent because those are intersecting, or it's intersecting the circle at one point. And here's a radius. So that means, and I'm just going to mark this here, not sure if it's going to be helpful or not, that means that those are perpendicular. They have to be. Additionally, if this is a diameter and that's a radius, that means that these are radii. So those are congruent. So that might be helpful as well. Okay, so something that might be helpful here, which I definitely think it's going to be helpful, is that if you look, this whole angle right there is said to be 106, which means that this angle right there is its linear pair. So if I do 180 minus 106, that'll give me 74. Okay, that means 74 is that little angle right in there. Now, remember how I previously said that if this is a tangent and that's a radius, that means these are perpendicular? That means that if I want the measure of angle A, I can do A plus, again, this is 74, equals 90. Those must sum to 90. So A equals 16. Yay. Okay, so that's how I got A equals 16. Now, from there, remember how I said these were radii, so that means those are congruent. Ask yourself, what type of triangle is this? Wouldn't that be isosceles? So that means that this angle over here must also be 16 because those would be the base angles of an isosceles triangle. Or if two sides of a triangle are congruent, the angles opposite them are congruent. Now, you know the sum of the interior angles of a triangle is 180, so I can do 16 plus B equals 180. So minus 32 gives me 148. Now, again, you could have come up with something different in order to do this. Like, for example, like if I mark this over here, that's 180. And I can recognize that this angle right here is 74. If I double that 74, that means this whole arc from C to B must be 148. That could then give you that central angle right there. You could also do the sum of the angles, or sum of the arcs of the circles 360 and help you determine this angle. That would help you get that central angle. Then there's another linear pair. I don't know if that really helps save you any time or anything, but there's a bunch of different things you could fill in this diagram. So again, I just took you through one solution of this. You may come up with something different. Just make sure you're showing your work is really what's important. All right, so this concludes our video, which would be the end of Unit 13. So just to recap, we talked about big arc minus small arc divided by 2. When you have a radius and a tangent meeting at the point of tangency, they must be perpendicular. We learned about another example where we're taking half of the intercepted arc and that gives us the angle. So that's a tangent and a secant intersecting at the point of tangency. And then lastly, this is the one students tend to forget about, the average of the arcs will give you the angles created by two secants. So there you have it. So that's the end of our Unit 13 notes.